Imagine you have a superhero friend, like Flash, who can run incredibly fast now. Picture asking Flash to run back and forth across a park as quickly as possible. Over and over again. What would happen? Flash would get tired very quickly. But if you told Flash to take a short break after each run, he could keep going for much longer without wearing out. This concept is similar to something in JavaScript called throttling. Throttling is essentially a way of telling JavaScript to slow down and not execute a function too frequently. It limits how many times a function can run within a specific time frame. This is particularly useful in scenarios where frequent events, like scrolling a web page, resizing a window, or clicking a button multiple times, can cause JavaScript to overwork and slow down the web page, making it laggy. Throttling ensures that a function only executes periodically, even if the triggering event occurs repeatedly. For example, imagine you have a magic button that makes a balloon grow. If you click the button too quickly, the balloon might pop. To prevent this, you can throttle the button so it only works once every 2 seconds. No matter how fast you click. Here's how you can implement throttling in JavaScript. First, you create a throttle function that takes 2 arguments: the function to be throttled and the delay period. Inside the throttle function, you track the last time the function was executed. When the throttled function is called, it checks the current time against the last execution time. If enough time has passed, the function runs again and updates the last execution time. Otherwise, it waits. For instance, you might write a throttle function like this: function throttle, func, delay, opening curly bracket, let last time equals 0. Return function, args, opening curly bracket, let now equals date.now. If now, last time greater than equals delay, opening curly bracket, func, args, last time equals now, closing curly bracket, closing curly bracket, closing curly bracket. Then, you can use this throttle function to control how often another function, like grow balloon, is executed. For example, if you attach the throttled version of grow balloon to a button click event, the balloon will only grow once every 2 seconds, no matter how many times the button is clicked. Throttling works by ensuring that even if an event is triggered repeatedly, the associated function only runs at defined intervals. This makes it an essential tool for optimizing performance in scenarios like scrolling, where you can limit how often an event handler runs, or resizing the browser window, where you can prevent the function from being executed hundreds of times per second. In summary, throttling is a powerful technique for managing how often functions are executed in response to frequent events. It helps maintain smooth performance and prevents unnecessary strain on your JavaScript code. Common use cases include scrolling, window resizing, and button click events, where throttling ensures that your application remains responsive and efficient. Throttling is a technique used to prevent users from clicking or interacting too quickly, which could potentially break functionality or cause performance issues. Let's explore its advantages first. Throttling improves performance by reducing the number of times a function is executed, preventing laggy or unresponsive experiences. It also ensures efficient resource usage by limiting CPU and memory consumption, which is especially important for resource-intensive applications. Additionally, throttling enhances the user experience by enabling smooth scrolling and interactions without unnecessary slowdowns. Another key benefit is that it prevents unnecessary API calls, which is particularly useful in scenarios where continuous server requests could overload the system. However, throttling does come with some disadvantages. One drawback is the delay in function execution, as the function will only run at set intervals. This might not be ideal for time-sensitive actions. Another issue is the potential to miss events that occur within the throttle period, which could lead to incomplete or missed interactions. Lastly, implementing throttling can be complex, as it requires careful tuning of the delay value to strike the right balance between performance and responsiveness. In conclusion, throttling can be thought of as asking a speedster like Flash to take breaks so he doesn't exhaust himself. In JavaScript, it helps ensure that our web pages remain fast and efficient, even when users interact rapidly. By using throttling, we can create smoother and more reliable user experiences while optimizing resource usage.